Hello class, we're about to start section 6.4, linear inequalities in one variable. Our objectives is to graph subsets of real numbers on the number line, to solve linear inequalities, and to solve applied problems using linear inequalities. Graphing subsets of real numbers on a number line. In this section we will learn how to solve a linear inequality. A linear inequality in one variable where the highest exponent on the variable is 1 can be written in the form of ax plus b is less than or equal to c, where the inequality symbol can be less than or equal to, greater than or equal to, less than, or greater than. Solving an inequality is the process of finding the set of numbers that make an inequality a true statement. A solution set is the set of all numbers that satisfy the inequality. Now, I want to look at this table below. It says here, the table below shows how to represent various subsets of real numbers on a number line. Open dots or circles indicate that a number is not included in the set. Closed dots or circles indicate that a number is included in the set. Graphs of subsets of real numbers. Let a and b be real numbers such that a is less than b. Now we have here the subset of x is less than a. X is a real number less than a. If you notice here, it's an open circle. That means a is not included. And we draw our arrowhead here going to the left, which signifies that all of the numbers is less than a are included. And here we have the subset of x is less than or equal to a. So in this case, we will shade in this part because a is also included in the subset. Now we have the subset of x is greater than b, or the set of x is greater than b. X is a real number greater than b. We have the open circle because b is not included, and we know values to the right are greater, and we have our arrowhead. And here we have the same setup except for x is greater than or equal to b, so it's shaded in, and we have our arrowhead as well. Now, we have another situation here. This is where we have a compound inequality where x is greater than a but is also less than b. So if you notice, we have open circles on both of these values, and that includes all of the points in between these two values. Now, this situation is basically the same except for we have the or equal to. So that means it's basically the same except for these values are now shaded. Now we have a situation where 1 is or equal to and 1 is just less than. So we have the a shaded in and the b is an open circle because a is included and b is not. And then finally we have a is less than x, but x is less than or equal to b. And if you see here, b is shaded in and a is not. So that means b is included and a is not. Now, it says example, graph each set. We have the set of x where x is less than 5. Now here's the solution. We go on our number line, draw an open circle on 5, and draw our arrowhead going to the left. That signifies that it goes on forever. Now, and remember we use an open circle when it's just less than or greater than. Now we have the set of x where x is less than or equal to 5. This time we will put a closed circle on the 5 because the 5 is included, and still draw a line, the arrowhead going to the left. Now we have this compound inequality. We have x is less than -2, but x is also less than or equal to 5. So we will have a closed circle on 5, open circle on -2, and there's all the values in between them and 5. It says if the variable is on the left of the inequality sign, then the inequality sign will indicate which way the line will be drawn on the graph. Now we have solved linear inequalities in one variable. A linear equation in x can be expressed as ax plus b equals 0. A linear inequality in x can be written in one of the following forms. Ax plus b is less than 0, ax plus b is less than or equal to 0, ax plus b is greater than 0, and ax plus b is greater than or equal to 0. In each form, a is not equal to 0. Inequalities are similar to equalities. If the same value is added to or subtracted from both sides of an inequality, then the inequality is still valid. Now we have the addition property of inequality. If A is less than B, then A plus C is less than B plus C. Inequalities are also very different from equalities. If a number is multiplied or divided by the same positive value on both sides of the inequality, then the inequality is still valid. If a number is multiplied or divided by the same negative value on both sides of the inequality, then the inequality is changed. Greater than will become less than, and less than will become greater than. Now we have the multiplication property of inequality. If A is greater than B, then AC is greater than BC if C is positive. If A is greater than B, then AC is less than BC if C is negative. The procedure for solving linear inequalities is the same as the procedure for solving linear equations, with one important exception. When multiplying or dividing both sides of the inequality by a negative number, reverse the direction of the inequality symbol, changing the sense of the inequality. When we multiply or divide both sides of the inequality by a negative number, the direction of the inequality symbol is reversed. Now we have a few problems that we need to attempt here. We have our first example. We want to solve and graph the solution set for each inequality. So now we want to I would just say this. I've told you before, with regular equations, it doesn't matter which side the variable is on. That's also true for the inequality. However, if you put the variable on the left side, it will make it easier to solve. So let's solve by putting all of the variables on the left and everything else on the right. So first thing we would do is subtract 8x on both sides. 6x minus 8x is a negative 2x minus 12 is greater than 2 because these 8x's simplify out to 0. Now we will add 12 on both sides, and we will have negative 2x is greater than 14. Divide each side by negative 2, and x is less than negative 7. Now we solve this inequality. Now we want to graph it. Now I'm going to draw my graph up here because of the lack of space. Now again, we have 0. We could put negative 7. And remember, x is less than negative 7. So we'll put an open circle on negative 7. We will draw our line on the number line and draw our arrowhead. And so now we've graphed A. Now we will go over here to E. Now we have negative x over 3 is greater than 4. Now what we could do is this here. We could multiply this whole inequality by negative 3. And that would take care of everything. A negative times a negative is positive. These 3 simplify out and leave you x. But because we multiply by a negative, we have to change the direction of the inequality sign. And negative 3 times 4 is negative 12. So now we can do our graph here. At 0, to be negative 12, and x is less than negative 12. We'll put an open circle on negative 12 and draw a line from negative 12. Now, we scroll down here to B. We have x minus 7 is greater than 1. We add 7 on both sides, and x is greater than 8. So now we would draw our graph here. 0, 8, and then we know we will have an open circle. We will draw our line with our arrowhead. Now, we go here to F. We will add 7 on both sides. We will have 5x is greater than 75. Divide each side by 5, and x is greater than 15. So we draw our line so we can graph. We have 0, 15, and we know it's an open circle. We will draw our arrowhead. our line and arrowhead. Okay, now we come down here to C. We have x plus 12 is less than 21. So we will subtract 12 on both sides. We have x is less than 21 minus 12 will give us 9. Now, we want to graph this line here. I actually drew it a little too long, but that's fine. So now, we want to graph this. We notice this x is less than 9. We know it's an open circle on a 9 because it's not an or equal to. And then we will draw our line and our arrowhead. Now we come here to G. We will subtract 8 on both sides. We have negative 3x is less than or equal to 47 minus 8 is 39. We'll divide each side by negative 3. And x, since we divided by negative 3, we have to change the direction of the inequality. It's greater than or equal to 39 divided by negative 3 is a negative 13. So now we graph this. Now we have 0, negative 13. Now since this has the or equal to, we will shade in our point here and then draw our arrowhead. Now one other thing before we go to D here. The reason why we want the variable on the left hand side is because we could just follow the direction of the inequality. You notice this is pointing to the right. Our arrowhead points to the right. This one here is pointing to the left. Our arrow goes to the left. So that is the reason why we put the variable on the left hand side. Now for D, what we need to do for D is this here. We notice here that we have x over 7 is less than or equal to 5. So what we will have to do is multiply everything by the common denominator of 7. So we will multiply 7 by this whole equation, this whole inequality here. Now, so we could make this 7 over 1. We know these 7s will simplify out. That will leave us x. And 7 times 5 we know is 35. So we have x is less than 35. Now, we want to graph this. But before we do that, let me just take this off of here. One thing that we did not do that we needed to do for all of the problems is we needed to write this as a solution set. We need to draw our line, our x, and then also our braces. So what I'm going to need you all to do is go back in your notes and write all of these as solution sets. So I would try and write all of these as solution sets. Go back up here. Just have to make a few little corrections. So we have to write these answers properly. Scroll back up here. So we write our answers as the solution sets. Okay, now we come back down here. We have the solution set of x as x is less than or equal to 35. And now we want to graph it.